Hey guys, this is Baxter. He was kind of sad, so he's sitting on my lap and helping me film the video. So he may or may not pop in, but just wanted to introduce him. So, anyways, we're gonna kind of build on what we did yesterday in class with connecting the f and f prime graphs, but we're gonna do it analytically, right? Analytically means with an equation instead of with a graph. So, just kind of first note, I want us to just write a definition up here, and that's gonna be the critical point. So we talked about this a little bit yesterday, but basically critical points are the points at which f prime of x equals 0. Now technically it's 0 or undefined or DNE. For today's lesson, we're really only going to worry about the 0. The DNE case only occurs when we have rational functions. With a fraction where, say, the denominator was 0, or possibly with some of those other cases where we'd get an undefined domain, but they're pretty uncommon. So, right now we're really going to focus on just the equal to 0 part. So, kind of off on the side, if you want to, is we're going to follow this process that we're going to do today, but kind of some keywords that we want to watch out for that are going to just give us a hint that we're going to be using this process are if they ask us to find the critical points, if they want us to find intervals of increasing or decreasing, or if they want us to find relative extrema. And what an extrema is it's either a maximum or a minimum. So when we see the word extrema means a max or a min, kind of asking us to solve for both, right? So if they say find the relative max, you're only looking for the max. If they say the relative min, you're only looking for the min. But if they say extrema, you're looking for both. So that's kind of what we need to know going into this. So reading through this, it says for each of the given functions, determine the intervals on which f of x is increasing or decreasing. So immediately we know we're going to be using this process. And then it also says find all coordinates of the relative extrema. So we're going to go through and just kind of look at how we're going to do this. So our first step, whenever we're doing any of these three things, our first step is to always set the derivative to 0. So to take f prime of x and set it to 0. So f prime of x here is 3x squared minus 6, and we're going to set that equal to 0. So we'll solve, we'll get 3x squared equals 6, x squared equals 2. Take the square root of both sides, and we get x equals plus or minus square root of 2. We always do the plus or minus when we're solving for an x. Right, when we're plugging in, that's where we didn't necessarily always do it if it was a function. But when we're solving for x, when you take a square root, you always add the plus or the minus. So these two, the x equals plus or minus square root of 2, those are the location of my critical points. Now, in this question, they didn't ask us to do this. But if we wanted to actually find the actual critical points, what we would do is we would take square root of 2, and we'd plug it back into f of x. We'd take negative square root of 2, and we'd plug it back into f of x. Okay? And so I went ahead and did that for you guys. So, 1 minus 4 square root of 2 would be the y value when we plugged in square root of 2 to the original. And 1 plus 4 square root of 2 would have been our other y value. But this question didn't ask for the critical point, so we don't really need to worry about that. I'm just kind of showing that because on the homework, we may have to do that. So if we were actually finding the critical point, a point has an x value and a y value. But in this case, they didn't ask that. They only asked to find the increasing and decreasing intervals and to find the relative extrema. So we're going to go ahead and not even worry about plugging it back in. We're just going to solve for the x value, and then we're going to move on. So kind of our first step, if you want to just kind of add on to your notes, you could use another color if you want to. But our first step was to basically take f prime of x equal to 0 and solve for x. And then our second step is going to be to do what we call a number line analysis. And we're going to do a number line analysis for f prime. And so what that is going to look like is we're going to draw a number line. and we're always going to label our number line. So we're going to label this one f prime. And on our number line, we're going to put in the x values that we solved for. So we're going to put in negative square root of 2 and positive square root of 2. Now, you read left to right, right? The left side is like at negative infinity. The right side is at positive infinity. So we always go smallest to biggest values. So now on our number line analysis, what we're looking for is are our values of f prime positive or are they negative? And if you look, we kind of have three sections on this graph. So we have this section here, which is going essentially from negative infinity to negative square root of 2. That would be like section 1. Section 2 is going from negative square root of 2 to positive square root of 2. And then section 3 is going from square root of 2 up to infinity. So those are the three sections of our graph. Okay, now we do not want to plug in square root of 2 or negative square root of 2, because if we plug those in, we're going to get 0. We know we already solved for 0. And so we got negative square root of 2 and positive square root of 2. So we need to plug in values that are actually in those intervals. So that yellow interval, that first interval, we would be plugging in a value that's less than negative square root of 2. So we could plug in like x equals, say, negative 2 would work. If you weren't really sure what negative square root of 2 is, you could plug in like, say, negative 10. It doesn't matter as long as it's a number smaller than negative 2. Now, I never write this down. Okay, I just kind of do that in my head. So in my head, I'm plugging in negative 10. Now, if you want to write yourself a little note, write yourself a little note like, say, plug in x equals, I'm going to do negative 10, but basically something smaller than negative square root of 2. This is just like your note for how you do these questions. Okay, so I'm plugging in negative 10, and we're plugging it into f prime of x. So where we're plugging it into is we're plugging it into our derivative, right? We're doing a number line analysis. So 3x squared minus 6. So if I plug in negative 10 in my head, 3 times negative 10 squared is 3 times 100. 300 minus 6, and all I care about is, was it positive or negative? That's a positive number, right? 300 minus 6 is positive. I don't care what the answer is, just that it's positive. Next, in between negative square root of 2 and positive square root of 2. That's a really easy number to plug in. If we can ever plug in 0, do it. It's always the easiest. So we're going to plug in 0. So again, I'm not going to write down 0, just in my head, I'm plugging in 0. 3 times 0 squared. Right, we're plugging in here, like 3 times 0 squared in our head, minus 6. That 0 minus 6 is negative. Now, I don't ever write that down. The 3 times 0 squared minus 6, I just write, kind of do that in my head. Now, something bigger than square root of 2. Say like positive 10 or positive 2. I'll use positive 2, right? Square root of 2 is like 1.7 or something like that, so 2 would work. 3 would work, 5 would work, anything bigger than square root of 2. So 3 times 2 squared, that's 3 times 4 is 12. 12 minus 6 is positive. Okay. And so what we're going to do is we are going to just kind of draw in. Anytime it's positive, our graph is increasing. Right, we learned that yesterday. F prime is positive, F is increasing. Then negative, F is decreasing. And positive, F is increasing again. And so this graph is really going to help us out. We know, whenever that graph is going up, F was increasing. Whenever F was going down, it's decreasing. And going up is increasing. That black line is kind of what F is doing. That also means this point here, so it's at the top of that little like mountain, that's going to be a relative max. And this point here at the bottom, that's going to be a relative min. So this number line analysis basically tells us everything that we need to know about our function. But it does not justify it for us. If we didn't do anything else, we would get 0 points on our AP exam. Maybe we get 1 for like, that work up there. But we're going to lose a ton of points. So we need to make sure that we justify this and we know how to. So the first thing that this question asked was to find our intervals of increasing or decreasing. So we're going to write these out. So the increasing, we're going to say f of x is increasing for negative infinity to negative square root of 2, union from square root of 2 to infinity. Right, and the way I got that was this was the positive sections. So the yellow section from negative infinity to negative square root of 2 was positive, and the graph is going up. And from square root of 2 out to infinity, again, was positive, the graph was going up. Now, again, we don't get credit yet unless we say because, so same explanation as yesterday, f prime of x is greater than 0, and I like to add on, for these intervals, or at these intervals. You'd also just repeat, at negative infinity to negative square root of 2, union square root of 2 to infinity. And then same thing for the negative side. So f of x is decreasing for negative square root of 2 to 2, right? We saw in our number line analysis, that's where we had the negative section, the green section, because f prime of x is less than 0. Now we could say for this interval, or we could just say for, and repeat negative square root of 2 to 2. Okay, next we'll do our relative max and relative minimum. Why? Because they said to find all coordinates of the relative extrema. Now, when they say coordinates, this is important. Coordinates means the x value and the y value. So we did need to plug this in. Now, this is kind of a little bit weird, but sometimes they're going to just say find where, right? If we see the word where, that just means the x value. Or they might even say to find the x value. If we see coordinate, we want to go back and actually plug it in. So, the x equals negative square root of 2, that was our maximum. But plugging it in, right, negative square root of 2. Now, this is where it's a little bit tricky. When we're doing the coordinates, you plug it back into the original, right? So here in our number line analysis, why did we plug it into f prime? Because we were doing an analysis on f prime. We wanted to know, was f prime positive or negative? But when we actually find the maximum or the minimum or the critical point, right, those match up with f of x. Those are for f of x. So we plug those back into the original. So we know that negative square root of 2, right, was our maximum. And if we plug this back into the original, right, the original is up here. Okay, it's a little bit weird, but negative square root of 2, when we plug it in, we got was 1 plus 4 square root of 2. Okay, you could have also just used a calculator. So that's our coordinate. That would be the relative maximum. Why? Because, same reasoning as yesterday, f prime of x changes from positive to negative. You could have also said like f prime of x greater than 0 to less than 0. And I'm going to say at x equals negative square root of 2. So it's always at that point, right? For these, it's always at a point. So it's at that x value. Then the other one, square root of 2 is our minimum. Right on the graph, that's the bottom point. And when we plug this in, we get 1 minus 4 square root of 2. So that's our relative minimum. And same reasoning. So is our relative minimum because f prime of x changes from negative to positive at x equals square root of 2. Now, I want to be very careful about these words negative and positive, right? F prime is negative, and it changes from negative to positive. That's kind of what we did in red, right? F prime was negative, now F prime is positive. You actually technically could say here, you could get full credit for saying F changes from decreasing to increasing at x equals square root of 2. That would be the same explanation. So you don't, either one of those two explanations works, but don't mix them up, okay? F prime goes from negative to positive, or you could say instead F goes from decreasing to increasing. That was what the black line was. F went from decreasing to increasing. But do not mix those two up, okay? I like to say, F prime goes from negative to positive. I like to always just, relate it to F prime. And that's easier for me. But every now and then you will see a textbook use this this other way of writing it, and that's the exact same thing. Okay, that's the table from yesterday, right? We learned both of those ways, but just don't mix it up. Don't say f prime changes from decreasing to increasing, because that's wrong. Okay, if you're using f prime, it's negative to positive. Okay, so our next one, f of x equals 3x to the 5th minus 5x cubed. We're going to go through this exact same process. So we want to find the intervals where it's increasing and decreasing, and then find the coordinates for the relative minimum and the relative maximum, the extrema. So that first, and if you were taking notes, right, the first step was always to do our, f prime of x equals to 0, solve for x. The second step was to do the number line analysis, and then I kind of skipped writing out. Our third step would be essentially to answer the question with justifications. And so we'll practice these justifications. It's kind of almost like a little bit of a sentence starter. It's like, f of x is increasing at these intervals because blank. Or, x equals whatever is our relative maximum because blank. And if they ask for coordinates, then we need the x and the y point. So here, same process. First step, we're going to say f prime of x. In this case, we're going to get 15x to the 4th minus 15x squared. And we're going to say that that is going to be equal to 0. Right? We're setting it equal to 0 to solve for those horizontal tangents, because that's where we're going to get increasing and decreasing, and that's where it's going to change right from increasing to decreasing and give us our maxes and our mins. So that's why we're setting it equal to 0. And those are called our critical points. So we can solve by factoring out a 15x squared, and that gives us x squared minus 1 is equal to 0. Now, when you're solving this, some of you guys might be able to do this in your head, but I like to kind of think either one of these could be equal to 0. So I write 15x squared could equal to 0, or x squared minus 1 is equal to 0. Whenever I'm solving and we factor, I always kind of do this as practice. So this side gives me x equals 0, right? Divide by 15, take the square root. And this side gives us x squared equals to 1, so we square root it, and we get x equals plus or minus 1. So we actually have 3 critical points here. We have 0, negative 1, and positive 1. And I don't need to plug these in yet because they didn't ask us to find the critical points, at least yet. So we're going to do just f prime and do our number line analysis. Now, the smallest number is going to be negative 1, then 0, then positive 1. And so we're going to plug in. And the best place to plug in is always where you have it factored. So you always want to plug in where it's factored. It's going to be a lot easier to plug in here where it's factored. You could have plugged into the top line, the 15x to the 4th minus 15x squared, but we're going to see that it's a lot easier to do our number line analysis where it's factored. So remember, we're plugging in numbers in our head. A number smaller than negative 1 is, say, like negative 2. So we're going to plug in negative 2 in our head. Negative 2 squared is positive, and times 15 is positive. So I'm just going to put a little plus here. And then negative 2 squared is 4. 4 minus 1 is positive. So what we're doing is we're doing a positive, essentially, times a positive. A positive times a positive is a positive answer. Okay, next we're going to plug in something in between negative 1 and 0. Like, let's say, negative 0.50. So we're plugging that in. Now, you don't need to write that down. I'm just putting that for us. So we're going to, in our head, plug in negative 0.50. Now, I'm going to get rid of the positive and the negative here. So negative 0.50 times itself is positive 0.25. But again, I don't care about the answer. I just care is it positive or negative. So when we square it, we get a positive. Now, this x squared minus 1 is a little trickier because negative 0.50 squared is positive, but it's positive 0.25. And 0.25 minus 1 is negative. So a positive times a negative gives us a negative answer. Okay. Then our next one is going to be at, like, say, 0.25. Okay, and 0.25, when we do 0.25, it's going to be the same thing. 0.25 squared is positive, 0.25 squared minus 1 is negative, and a positive times a negative gives us a negative. And here's something, say, bigger than 1, like 2. 2 squared is 4, and 4 times 15 is positive. Then 2 squared is 4, 4 minus 1 is positive. So a positive times a positive gives us a positive. So again, all we were really caring about was the sign. Was it positive or was it negative? We don't care what the actual answer is. And so now, if we kind of just graph in what this would look like, we're increasing. Now we see that we're decreasing twice in a row. How I like to do these is, decrease it at one angle, and then here, right here, kind of put a point there and decrease it at another angle. Okay, and I'll put some points there. So we can see that, -1 is kind of like our maximum, our relative maximum. And then here we're going to have a neither. It's neither increasing nor, it's neither a maximum or a minimum. And that happens, right? We see that up here, this was definitely a minimum. This guy was a maximum. But you can get, a maximum, and then you could get like a minimum, and then you could get kind of a horizontal tangent and a neither. So this guy's a neither. And it's where, maybe you're increasing, and then you keep increasing, or you're decreasing, and then you keep decreasing. And that happens for like y equals x cubed is a very common one, right? Y equals x cubed that happens for, where it pauses, it's increasing, then it stops increasing and kind of pauses, and then it increases some more. And so you get a critical point, you get a horizontal tangent line where the slope is 0, it pauses, but it's not a maximum or a minimum. So that's what happened at x equals 0 on our graph. Okay, so now we're going to just fill in, that was step 2. Now step 3 is to kind of write our answers and fill it in. So we're going to say f of x is increasing for -infinity to -1, the positive spot, union 1 to infinity. Why? Because f prime of x was greater than 0 at these intervals. I always like to add the at. And then the next one, f of x is decreasing for -1 to 0, union 0 to 1. So don't go from -1 all the way to 1. It pauses at 0. Why? Because f prime of x is less than 0 at these intervals. And then if you want to kind of have a sentence starter, we can always start with f of x. We could say f of x has a relative max. Now, if it just asks for the x value, you would say at x equals -1. Okay, but in this case, it didn't ask for the x value, it asked for the coordinates. So we're going to say at -1, comma. Now, we don't know what the y value is. And this is important to kind of realize is, in this case, right, the -1 to 0, union 0 to 1, those were intervals, okay? Those were intervals. But here, it's going to actually be at a point. So it's an x and a y value, okay? And, it's because a maximum is at a point. So even though they both have parentheses, we want to be careful about that. So for the -1, we need to plug that into the original, right? So f of -1 is 3 times -1 to the 5th minus 5 times -1 cubed. And we get 3 times -1 is -3 plus 5, so we get +2. So -1 comma 2 is our maximum point. That's the maximum value. Why? Because f prime of x changes from positive to negative at x equals -1 at that point. Again, we could have said f changed from increasing to decreasing, but I prefer this explanation. Okay, and then our last one, f of x has a relative minimum. Now, our x value is at +1. That's where our minimum was. So at 1, comma, now we're going to plug in 1 up here. Right, f of 1 is 3 times 1 to the 5th minus 5 times 1 cubed. 3 minus 5 is -2. so at 1 comma negative 2, because f prime of x changes from negative to positive at x equals 1. Now, if you're asking when do I know, when do I plug it into the original and when do I plug it into the derivative, you're always plugging into the derivative when you're doing the number line analysis, when you're doing those testing points. And then if you're actually just trying to find the coordinate of f of x, like for the coordinate of the max or the min, that's when you're always plugging back to the original. Okay? So we're going to do one more of these with trig. And the ones with trig generally have an interval, a starting and an ending point, usually at 0 to 2 pi. So instead of going out to infinity, negative infinity, we start at 0, we go to 2 pi, right? That's just kind of one time around the unit circle, right? Starting at 0, going around the unit circle, and kind of ending at 2 pi. So it's one revolution. So that's kind of why they do that. So we definitely need to know our unit circle for these. So the first step is the same, f prime of theta equals 1. Now, the derivative of sine is cosine, so 1 plus 2 cosine of theta. And we're still going to set that equal to 0. Okay, so we subtract 1 from both sides, divide by 2. You'll get cosine of theta equals negative 1/2. And to solve for this, if you want to write something down, you can write down inverse cosine of both sides. And essentially what that does is it cancels out the cosine, but what it's really saying is where does theta, when you plug in cosine, where does cosine of theta give us the answer of negative 1/2? So if you remember kind of the table, right, sine, cosine, and tangent, that table, right, I'm not going to write out the whole table, but right, we start at 0, we went to like 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And then kind of coming backwards was 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Right? We're looking for the cosine is a half, so that's at this pi over 3 slot. Right? So this pi over 3 slot, that's where it gives us cosine is 1/2. So the answer is not pi over 3, but it's a multiple of pi over 3. So because of the negative, right, the negative is in the s and the t quadrants for cosine, right? So pi over 3 in the sine is going to be 1 less than the denominator, so 2 pi over 3. And in the tangent, it's going to be 1 greater. If you're not good with your trig, you really, really need to practice this. So that means that our answers here would be theta is equal to either 2 pi over 3 or 4 pi over 3. So those are our x values for the critical points. Right, for the y values, you'd have to plug it into the original. But we're going to start off with our number line analysis. Now, something new on this one. I drew it with arrows, and that's technically actually a mistake, and it could cost you this question. So whenever you have an interval, you actually want to get rid of those arrows, and you want to change those arrows to endpoints, kind of, I use brackets, right, and it's from 0 to 2 pi. This is important because before, on these, when we were doing this, I could have plugged in anything bigger than 1. I could have plugged in 2, I could have plugged in 10, I could have plugged in 100, and I would get a positive answer. Here, you cannot plug in anything. So when we do 2 pi over 3 and 4 pi over 3, we cannot plug in anything bigger than 4 pi over 3 here. We have to plug in something in between 4 pi over 3 and 2 pi. Okay, so I like to use my, when I plug in, I like to go back up here and use my all students take calculus. Right, 2 pi over 3 was somewhere in this quadrant, and 4 pi over 3 was in this quadrant. And when it's possible, I like to plug in my endpoints. Right, when we plug in our endpoints, then to me it's a little bit easier because they're all either 1 or 0 for sine and cosine. So that's, if we can, that's what I do. So something that's less than 0 and bigger than 2 pi over 3 in this section, right, that would be that point here, that pi over 2 point. So we're kind of plugging in pi over 2 in our head. And the coordinate there is 0, 1. right? And we're plugging it into the derivative, right, to f prime. So we're plugging in for 1 plus 2 cosine of theta. So the theta value is the cosine of theta value is the x-coordinate there is the 0. So when we plug that in, right, 1 plus, I'm going to kind of write it over here, 1 plus 2 cosine of pi over 2. You don't have to write that down. We're doing that in our head. That goes to 0. So 1 plus 0 is a positive value. Then next, in between 2 pi over 3 and 4 pi over 3, right, would be pi. So if we plug in pi, 1 plus 2 cosine of pi. Now pi is negative 1 for the cosine of pi. Cosine of pi is negative 1. So 1 minus 2 is a negative value. So this is a negative value. And then 4 pi over 3, in between 4 pi over 3 and 2 pi, is we could plug in 3 pi over 2. And at 3 pi over 2, we get 0, 1 again. So we're plugging in and we get 0 again. 1 plus 0 is positive. Now, something about sine and cosine on these, just kind of a shortcut, little bit of a hint, is what do those graphs look like? They always kind of just bounce back and forth. So a big hint is if we look at our critical points, they're always going to be maximum and minimums. They're never going to be those weird, kind of ones that pause. So unless you have a squared or something weird, like, if you have a squared or a square root or something in there, it's different. But if you just have a normal cosine or sine, this is always going to switch positive, negative, positive. So kind of a shortcut if either you're not sure what to plug in to, say like on the homework, there's one where it's kind of hard to figure out what to plug in this last section. Just remember that it always just flips positive, negative, positive, negative. Or, if you're running short on an AP exam you get a cosine one, you could just plug into the first, you get positive, and then just immediately say, oh, the next one has to be negative, the third one has to be positive. So that's kind of a little bit of a shortcut for you guys. So anyways, looking at what this would look like for our F graph, right, we're positive, so we're increasing, we get a maximum up here, we're decreasing, we get a minimum, and we're increasing. So, right, f of x, kind of looking at our answers, f of x is increasing, right, our kind of sentence starter, for 0 to 2 pi over 3, right, we're not using negative infinity more because we have the endpoints, the 0 and the 2 pi. Union 4 pi over 3 to 2 pi. Why? Because f prime of x was greater than 0 at these intervals. Then we'll do the same thing for f of x is decreasing from 2 pi over 3 to 4 pi over 3 because f prime of x was less than 0 at this interval. Or we could even say, if you want to, you could even just repeat it at 2 pi over 3 to 4 pi over 2. So you could either do that or you could say at this interval. Okay, then for our maximum, I'm going to just use our sentence starter. F of x has a relative max, and it's at this 2 pi over 3. So at x equals 2 pi over 3, now it's a point. So we're going to write it as a point. If you don't want to write it as a point, I know some people get really confused, like I said, because they're like, wait, why is this one an x and a y, and this one's an interval? So the other way you could write this is you could write at f of, if you want to write the coordinates, you could write f of 2 pi over 3 equals, right? And then that makes sense for why we're plugging it into the original. So we're going to plug this into the original, right? F of 2 pi over 3 would give 2 pi over 3 when we plug in for theta, plus 2 times sine of 2 pi over 3. Now, sine of 2 pi over 3, right, if you look on your table, the pi over 3 spot for sine is the square root of 3 over 2 slot. And 2 pi over 3 is 1 less, so that's in the positive case for sine. So we get 2 pi over 3 plus 2 times square root of 3 over 2. The 2's cancel, so we get 2 pi over 3 plus square root of 3. So you either could have written this, or if you wanted to, you could have written the same thing, but kind of right here, it has a relative max at 2 pi over 3, comma, 2 pi over 3 plus square root of 3. That's the x value and the y value. So either one of those two, I'm just going to put a little or here, right? Either one of those two would be right, and then we need the same explanation. Because f prime of x changes from positive to negative at x equals 2 pi over 3. So that's always going to be our explanation for our maximums. Okay, and then for our minimums, I'm not going to write both ways. I'm just going to pick one. I'm going to use the bottom way. That's how I always write these. F of x has a relative minimum at, now this one was at 4 pi over 3, right? That's where we had the minimum. And when we plug that in, I'm going to kind of do that one in my head. So 4 pi over 3 is for the theta, and then 2 sine of 4 pi over 3, that's in the negative quadrant, so it's going to be minus 2 times square root of 3 over 2 is the square root of 3. So we're going to get 4 pi over 3 minus square root of 3. That's going to be our coordinates. Why? Because f prime of x changes from negative to positive at x equals 4 pi over 3. Okay. So I know that's a lot. Honestly, a lot of times you don't actually have to plug these in. So only plug them in if it asks for the coordinates. And if it just asks, where does it have a maximum, then you can actually even skip that step. So I do want to show our homework really quickly. And we are going to have two homeworks, we'll do them in class together, but I do want to talk about this before you get there. So A says find and classify all critical points. Now, when it says classify, what that means is, either as a relative max, a relative min, or neither. So we do want to make sure that we're doing that for all of them, that they're either a relative max, a relative minimum, or neither. And then find the intervals where f of x is increasing and find the intervals where f of x is decreasing. And then this also asks us to sketch a graph. We didn't do that in our notes. So that's kind of one reason why I wanted to talk about this, just so we could kind of look at what this might look like in the notes, if we had done that. So in our notes, right, what might any of these graphs look like? So let's even go back up to the first one, because I think I had a little more here. No, we don't have room on any of these, but it's okay. So what might this look like? So if we were going to graph this, let me just insert a page here, give us more room. So if we were going to graph this, we knew that f of x was increasing from negative infinity to negative square root of 2. And we also have these points. So what I'm going to do is when I graph this, I'm going to actually graph those points. So negative square root of 2 is in between 1 and 4, really, right? We know the square root of 1 is 1, the square root of 4 is 4. The actual value of it is like 1.4, right? So it's somewhere, right here, 1.4, but you could even just kind of plot it, right? We're just kind of estimating. And then 1 plus 4 square root of 2, you might even not know what it is, but just kind of, this is negative square root of 2, just kind of put a point somewhere, negative square root of 2, comma, 1 plus 4 square root of 2, right? Just kind of put a point somewhere. And then over here, same thing, we have square root of 2, comma, 1 minus 4 square root of 2. And I know this is below the axis and that one's above the axis just because of the signs. The 1 minus 4 and 1 plus 4. Now, those are the only 2 points. Everything else is going to be a sketch. What a sketch means is it doesn't have to be perfect. Okay? And then what did we know? We know it was increasing, decreasing, increasing. So we're just going to kind of graph that. It's increasing. Then we're going to kind of level this out, make sure it's horizontal tangent there. Decreasing. And level this out. And then just put arrows. So the key is we really want to make sure that at that bottom, right, that it's really leveling out at that bottom. That if you needed to, you could have, drawn a horizontal tangent there. That it levels out there. Same thing up here, that it levels out up there. So that's the key on these sketches. Right, you also could have looked up here and realized, hey, it's an x cubed, so we should have, basically on an x cubed, we should have two kind of humps, right? Like, this kind of downwards, basically like a mountain, and then this kind of valley, right? You have two of those, like I call them humps. But, x cubed you would have 2, x to the 5th you would have, a maximum of 4. You don't always get them if you have repeat ones. If on this one we won't have as many because when you factored it out, we got that 15x squared. So we'll kind of look at this one too. Okay, so on this one, if we were going to sketch this one, we know that we have points at, this one has easier points. We have points at -1, 2, and +1, -2. So we have points at those two. And then, I'll use another color. So if we were going to sketch this, right, those are the 2 points we know for sure are on our graph. Now, what was it doing? It was increasing, decreasing, decreasing, and then increasing. So at 0, 0 is also a point. 0 was a critical point. So if we classified kind of 0, right, on the homework it said to classify the critical points. So 0, now when we plug in 0, 0 to the 5th minus 0 cubed is 0. So 0, 0 is neither a max nor a min. And if you were going to justify this, it was, because f prime of x does not change signs at x equals 0. Or you could say, f prime of x basically stays decreasing at 0. So there's our next point. So now, what were we doing? We were increasing before -1. So we were increasing. We're going to kind of draw this smooth to level out. Now, you want to be careful here. A lot of people just draw a straight line. It's not a straight line. It's going to come down, and it's going to kind of level out. So it's going to level out, and then it's going to keep decreasing. Right? So here at x equals 0, that's like that x cubed graph, right? That's like that point right there. So you kind of want to draw it as coming down, then leveling out, and then coming down again. Okay. And so how did I know to graph it this way, right? Because before 1, it was positive, it was increasing. Then after 1, from -1 to 0, it was decreasing, it was going down. Then I'm going to level it out at 0 because it was a critical point, but I'm going to keep it decreasing. So they're always going to level out, but then it's going to decrease some more. And then here it was increasing afterwards. So that's how you draw those sketches. On the homework, I was a little bit mean. I did not give you the answers for those sketches. So we do have an answer key. And we'll do this in class together, so we'll talk about them. But the answer key does not have sketches just because there are so many different kind of possibilities. So anyways, the rest of the homework shouldn't be too bad. But that's that. Now, we are going to have kind of 2 homeworks tonight. We're going to have that one, and then we're also going to have day 15 homework. Okay, and day 15 homework is kind of a combination of today's lesson and yesterday's lesson. It's only 5 questions, but it's kind of that just kind of combination of, hey, here are a few that are analytical, and let's make sure we can do them. And then here are a couple that are graphical, and let's make sure that we can do those. So anyways, there's that. For number 3 here, make sure that before we can take the derivative that we expand that out. And then the rest of it should be pretty straightforward. So if you guys have any questions, either email me or make sure that we talk about them before we go into breakout rooms tomorrow.